We'll now demonstrate how to conduct a Manova with SPSS.
Remember again, it's going to be a one-way Manova, meaning we have one independent variable, and that independent variable is going to be grade. Grade 6, grade 7, and grade 8. But there are three dependent variables. The null hypothesis is that there will be no significant difference between the three packages of dependent variables across the grade levels. The alternative hypothesis is that there will be significant differences. The dependent variables in this case are going to be the pacer, push-ups, and curl-up from the fitness gram.
Here's our first result from a multivariate analysis of variance, Manova with SPSS. We'll walk through these and then we'll demonstrate how to do a Manova with SPSS. Our first piece of output is descriptive statistics. Notice we have each dependent variable listed, the pacer, push-up, and curl-up, the mean values for each the 6th, 7th, and 8th grades.
And we have a total of 200 subjects.
This is the important piece. This is the multivariate analysis of variance source table. It looks a bit like what you saw with univariate analysis of variance, but importantly, we want to look at the student grade. Student grade is the independent variable. And as we previously indicated, there are 4 test statistics: Palloy's trace, Wilks' lambda, Hotelling's trace, and Roy's largest root. As we indicated, Wilks' lambda is the most frequently reported test statistic for Manova. But in our case, it makes no difference which of the 4 test statistics you use. In each case, you reject the null hypothesis. The significance level for each of these is 0.000, which is technically 0.0001 somewhere out in the extreme. Notice, though, that there are differences in the F value associated with each test. Notice that there are differences in hypothesis degrees of freedom and error degrees of freedom. That's why you get slightly different results in this case. Another piece of output that often comes with Manova results and does with SPSS are univariate results. Think about it this way. The omnibus or overall test, the Manova test, said there's something going on with this package. After you've learned that there's something going on, you can then go back in and do univariate tests, and that's most often done to find out where those differences are. In our case, if you take a look at the student grade effect, we have univariate tests for the pacer, the push-up, and the curl-up. If you looked at the significance values on the right-hand side, if these were univariate tests, you'd find out which ones were actually significant. But running the Manova gives us some protection about the overall type 1 error when you run a Manova. But notice, if you did a univariate test only, the push-up is not significant. You could then go back and look at the descriptive statistics and see what the mean values are for the pacer, the push-up, and the curl-up to better interpret what your results mean. We'll now move to illustrating how to conduct a Manova with this data set.
As usual, here is our data view SPSS sheet that shows we have an independent variable, student grade, and our 3 dependent variables, the pacer, laps, push-up, and curl-ups, 3 physical fitness tests.
So in a sense, we want to test whether or not this package of fitness variables differs as a function of student grade, grade 6, 7, and 8. We go to Analyze, down to General Linear Model, Multivariate, take the student grade, it's a fixed factor, it's the independent variable. Take the 3 fitness tests, the pacer, the push-up, and the curl-up. Those are dependent variables. Click on Options, click on Descriptive Statistics, click on Continue, and then OK. And here are our results. The first check tells you that there are 71 students in grade 6, 64 in grade 7, and 65 in grade 8. Here are our descriptive statistics, just like you've seen in the previous slides. Here's the multivariate test, where you have 4 different test statistics. And then finally, you have the univariate results. You only should interpret the univariate results if in fact the multivariate test is significant. Running a Manova, while the logic is the same as a univariate test, it's a bit more complex mathematically, but running it with SPSS is really quite simple.